So today we're actually going to tell a little bit of a story of something that happened at Dagger, where we will trying to fix our continuous deployment pipelines. Internally, we're currently using Argo CD to do a continuous deployment operation over Kubernetes. We have a few applications. Those applications are defined like within our repository on a specific path. Argo CD continuously watches that specific path for new changes, and then just does a conciliation loop of constantly trying to reconcile and deploying the latest changes that you applied. So let's say you're iterating over your API, you made a change. The idea is that an image should be built, published, and then a new commit should be automatically added that changes the deployment file, adding the new image that was published, and then Argo CD should automatically pick that change up. Now, I'm not going to get too much into why we did the approach this way. There are definitely other alternatives. If you're curious to know why, or you want to discuss this a bit more, you can join the Kubernetes channel on Discord and we can discuss that one. So we're just going to go with what we have. Now, to implement this, I went through a small journey and it actually ended with Dagger. So I thought it would be cool to show it. Now, we said that what we need to do is once an image is published, grab the URL, update a YAML file, commit, push, that's it. So how can you build that? We're using GitHub workflows. The first thing that you can do is you can leverage some out-of-the-box GitHub Actions. For example, right here, we have a YQ GitHub Action, which is like JQ. It just allows you to modify, to very easily modify YAML files. You can basically change the thing that you want. So you have the infra deployment file that you can update. You can say, hey, to the container image, update it with this GitHub show, and then just update it in place, right? Once you do that, since we're in the context of a GitHub action and everything is stateful, then the files that were in the repository were changed. So we can just commit and push it to our main branch, and we should be fine. Now, when we did this, we faced a few problems. The first one is I cannot test it locally. Like, this is a workflow that I cannot easily test it locally. I just want to make sure that my logic of changing a file and updating it and committing and doing all that stuff, I cannot reproduce it very easily locally because I'm using GitHub Actions. The second problem was that before doing all of this, there was a very, some heavy lifting happening prior to this, which meant that when we got to the point of doing this, new commits might have already popped up into the repository. And since we check out the repo, this doesn't really work if someone already merged the PR, for example. You're going to have history locally you're going to have history in the remote that you don't have locally. So what can we do? Well, we can very easily add a git pull, right? We could add a step right here that does a git pull, or at least that's what I thought. You actually can't because the checkout is on a detached head, and you would require some mangling to actually check out the specific branch that you want, bring the latest changes, and do all that stuff. And we already said that this cannot be reproducible locally, so let's fix that. And of course, the fix for that is bash. You probably knew that. This could very easily be a bash script that's separate on that. It doesn't have to be in line in the workflow, but for demo purposes, we just put it here. What does this do? Well, it installs the things that it needs. It creates it basically downloads the repository. It makes the change with YQ. It adds the file, commits it, and this is wrong, pushes it to a branch, adding the possibility to do a force with lease. In our case, we have protected branches, so only admins can override that, and you have to override it with force, but you always want to use force with lease to not break the history. Now, this is amazing, right? Well, it cannot be reproduced very easily locally either because someone needs Linux with apt installed. That's not great. So what could we do? We could write a Docker file that installs all the things, mounts the bash script, runs everything that it needs to run. But that's not fun, or at least not for me. And we're working at Dagger, so we kind of need to, it makes sense to do some dogfooding. So what do? We say, hey, someone probably already solved this problem. Let's go and find some modules that do this for us. Well, we didn't find one, but we decided to build it. Now, this final workflow uses a Dagger module that's called image updater. You can find it on Daggerverse, you can find it on GitHub. You can look at how it's built. This is a little bit smarter than what we showed previously. It basically has a retry loop where it pulls the changes It pulls the repo, makes the changes, commits them, and push them. And if the push failed because there's history on the remote that we don't have locally, it just retries, like does a git pull again, and retries until it succeeds or until a configurable amount of time like happens, right? So what are we doing here? Well, telling the image updater to look at the important repo, to look for the deployment YAML file on the main branch, and to update that deployment file with this particular URL where we're using like the commit shop. And we're specifying some like credentials to basically tell it who should be the one that commits this particular change. And then we're adding a force with leaves because we are in a protected branch. So we want to make sure that we can override that protection rule. So time for the demo. Let's see if it works. Here we have an example repository. It's called Actions Test. I was basically testing action stuff, so I decided to use it. We have our deployment YAML file that we mentioned previously, and we're basically going to just tell it to update for let's do demo 4 and run it. You can see that the env path token, it's specified there. I already configured it because I don't want to expose that one. Sorry, Gerhard. So this should run fairly quickly. I have like most of the layers cached. And if I go back here and go to the repository, I can refresh and we should see a commit here, which actually has a bug. And I'm going to give a few seconds to see if someone can find it. But if we look at the commit, we can see that the change that was made is the demo 4. I'm using a version that has a bug. If you didn't find it, I'll just tell you. We're missing like the configuration of the date. So we made a commit 55 years ago. So if you go to my profile, you're going to see in my history, let me see if I can go right here. You're going to see that I have commits going back to 1969. So that's good. I was born in 1995, but anyway. So yeah, that's the module. This solved a specific problem at Dagger. And it was fun to go over the journey of how you can actually progress from bash hell to a reusable Dagger module that anybody can leverage. And that's the end of my demo. Thank you.